Hello and welcome to another session of me learning Kyma. So we had a little bit of a outage, or let's say a little bit of a break since our last session. So yeah, we are picking it up again, and today we want to kind of warm up with something that's available on developers.sap.com as a tutorial or as a mission. Because we will learn, I think, some things about Kubernetes, a little bit about Knative, and look a bit behind the scenes of what we did last time when we created a function in Kyma. So I will not go through this tutorial each and every step, because we did already some things last time when we created, for example, the commerce mock. That's also one step in here, as you can see. So this is creating a commerce mock. So I assume that this one is already in place. And in order not to annoy you with a lot of Docker builds, which is within each and every step here, I already created all the containers beforehand and pushed them to my container registry. Nevertheless, we will take a look into the details of the Docker file in order to understand what happens there. Nevertheless, all the tedious footwork I have already prepared. Now, before I start, one, let's say, announcement or something that I just got aware of. As you can see here, down below, Kyma got updated on the trial landscape, which is cool. And there is also now this metrics coming in, and there is the logs got now a kind of a jump away button or jump off button, which now directly leads you to a Grafana dashboard. So we have here Loki, as we know, for the log aggregation. We have Prometheus. We can look at the logs, we can look at the metrics. So that's, I think, quite nice. So I think this will be covered in another episode here, but that's really a nice present right before Christmas. Okay, so let's start with a short recap what you should have in place from the last session. So you should at least have in place the mock application, which was the mocking of the Commerce Cloud. So you should have the Commerce Cloud in place here with the local APIs, the remote APIs, which is then connected to your trial landscape, which you can see on the one click on the wrong place, on the system landscape level. So you should have at least one system here. I have two systems. So I think last time or the time before, I asked myself the question if you can delete those systems, and the answer is no, you can't not delete them. There is a feature request in order to delete them, and it's not possible until now. Strange, but that's how it is. However, formations, there was a bug within the trial landscape, funnily. So now you can delete formations by removing this and that. So at least I thought that was possible. I tried that this morning. So that should be possible now. There was something not rolled out, obviously, in the trial landscape. So nevertheless, this is what you should have in place. So you have a system that's paired with your commerce mockup. You have a formation where you link this system and the sub account to overall global formation. And then you should have, from an integration perspective, hook those things up. So there is a MP Commerce Mock 2 serving, which is kind of the link to the Commerce Mock thing. And here we have all our services exposed. So now I had to rename that because the first information was already there. So I think we have to take care about that when we deploy things into the system. But let's take a look later. So now what will we do today? Or what's the idea behind this mission? The idea behind this mission is you have, let's say, a full stack application with persistency, with an API layer on top of that persistency that's implemented in Go, and you have a front end. And then you kind of glue things together via a mechanism that's called trigger, that kind of tells your Kyma runtime that whenever an event arrives, or a specific event arrives, this should be routed to the API endpoint, and then this endpoint will store the information within the database, in the Microsoft SQL database that is also running on Kyma. Now, this thing here is something that you probably would not do in a productive environment, because you would probably hook in a service there in order to make use of that and not deploy the database itself, because if you use the database itself, you have all the tedious tasks coming along, security updates, backing up things, and so on and so forth. And this is something that you usually get kind of for free if you use a service, for example, from a cloud provider, and hook that into the endpoint. Nevertheless, it's quite interesting to see how things feel. So, yeah, let's dive into the topic. So let's start with deploying the Ms Sql runtime. So what's important, all the information is in a repository that we have already used quite some times. It's this Kyma Runtime extension sample, and all the different stuff is located in the, let's say, different folders of this repository. So first things first, what do we want to do? We want to deploy Microsoft SQL database to Kyma, running in a pod. And yeah, let's take a look at what's in this repository. So here I have my cloned extension samples folder, and the things that we want to take a look at are in the database Ms Sql folder. This is quite slim because most of the stuff is already within the Docker image that we are using. So we take a look at that file, and what we will see here is we have an image from Microsoft that contains the Ms SQL Server Linux. And what we do then is we create a little directory under user source. We copy our app folder there. So that's here. And yeah, then we do some making the shell file, the shell script that's called init-db executable, expose a board, and then we execute a command on bash line in order to make the entry point available. So let's take a look what's in this app file. So what we do is we call the init database, which kinds of waits a bit until the SQL server is coming up. So it's sleeping for approximately 1 minute, and then it executes SQL CMD on a specific port IP, using the user SA with the password Duke900, and then it executes this SQL file. So let's see what's in there. So here, what happens is it's creating a demo database. Then it says, okay, use this demo database, so we switch to it. Then it creates a table that's called orders with 3 parts in there: an order ID, a description, and a date time, which is defaulted by a built-in function. And then we insert 2 orders in order to see that everything is up and running. Okay. And then there was one more thing coming up, that was the entry point, which basically says start the SQL server and start the script, and in order to get things running. Okay. So basically we build a Docker file that contains a database that contains already some data and exposes I wouldn't say API, an access to it to the outside world. As I said, I already built the Docker image, so that's available within my container registry. And now the next logical step would be to push that to Kubernetes. And here we see now 3 different YAML files. So let's take a look and see what happens in there. So this is the classical deployment file that we have. We say we want 1 replica, and we want it from my container registry. We expose a container port here, and we inject some environment variables, which are needed in order to set up the database. Yeah. And then we have something that's important in order to log in, and that's the password. And we do not directly key in the password into our deployment YAML file, because this would be then, let's say, clear text in the in the Kyma dashboard, in the deployment description, but we reference here a secret. So secret is another object that's available, or a resource within Kubernetes that is intended to store your secrets. So let's shortly take a look at the description. So here we have the official documentation of Kubernetes, which shows us what are Kubernetes secrets. So they are basically a store for sensitive information that you want to store, like certificates, passwords, tokens, all that stuff that should not be stored within your configuration, but should be stored somewhere different, but should be accessible for your pods in a secure way. Yeah, there are several ways how to access then the secrets. So you can access them as a file in a volume mount for your containers. You can inject them via environment variable, or you can inject them or pull them from the secret store to your image when the kubelet itself is pulling the image during your deployment process. So there are different types of secrets that are supported out of the box. We have several ones for, let's say, Kubernetes specific tasks, like let's say a Docker config file, a Docker config JSON file, credentials for basic authentication, for SSH authentication. And we have one thing that's called opaque, which is arbitrary user-defined data. So and this is, as far as I have seen, the one that will be used here. So what we do here, we reference our secret. And we will take a look at that in a moment. And what we also do is we mount a persistent volume. That's something that we already did last time. So we have here a persistent volume claim with the claim name Ms Sql data that we have here, PVC, persistent volume claim. That is mounted here into the container, of course, in order to store data. And then we have a service. So as usual, we want to make the kind of internals of the pod accessible within the Kubernetes cluster within the namespace. So what we do here is we expose the SQL database as a service. So now let's take a look at our well-known persistent volume claim. We had that the last time, so we have here again a persistent volume claim. We use API version 1, nothing new. We give it a name, we say what is the access mode, and we say what storage or how much storage to claim for this persistent volume claim. Okay, that's known. Now let's take a look at the secret.yaml. That's new. So here we have a secret. So this special resource definition within Kubernetes. We give it a name as usual, we give it a label. And here we now have the type that I mentioned before, this opaque type, which is user defined. So let's switch back, arbitrary user defined data, okay, which are basically name value paths. Now, if you remember, within the Docker file, we had somewhere, not within the Docker file, within the app itself, we had this user SA and the password Ducon900. We don't see that here. The reason is that the data here is base64 encoded. So if we take that and go over to a base64 decoder, then we will see that this is SA. And if we take the second one, we will see that this is Ducon900. Okay. So yeah, that looks fine. So then let's switch to the database file. Before we start, we have to create a namespace because we don't want to have it within our default namespace. So we add a new namespace, we call it dev. We create that one. So here we have the new namespace dev. Let's shortly check kubectl -n dev get ports. This should return nothing. No resources found. Okay. So what we'll do now is we go to our database Ms Sql. We go to the Kubernetes. So here we have our three. Let's see if you can see that. That looks okay. Here we have our three deployment files. So we will now do kubectl -n development apply. So let's first push the secrets in. So the secret got created. Then we put in the persistent volume claim. Okay. And then we do the deployment. Yep. So now this should take place. It's already running. So yeah, it takes a bit of time until things kick off. So what we should see already is a secret. Yeah, this is this Ms Sql secret that we have here. With the base64 encoded stuff, we can also decode it here. That's a very nice feature. Yeah, that's the secrets. We have the persistent volume claim that we don't see here within the overview. But we should have the deployment. So this is now taking a bit of a time until it's up and running. So you have to wait a bit. let's see. Now let's things go a bit, and let's see what happens in here. So we did all the things. Yeah, I mean we can do that, but I think it's still initializing. Yeah, so that takes a bit of a time, because it has to start up the database, it has to execute the scripts. As you have seen, the initialization scripts also wait 60 seconds until everything is up and running. So let's check what we have. Now what's interesting here, and that's something that I definitely want to do, is connecting from my command line to the container or to the pod, and then execute a shell within the pod and execute Sql CMD, so the Sql command line interface, in order to access the database. So let's see how far we are. So this looks okay. So we have the deployment up. The pod is running. The service is running. Great. Don't jump too much. So what are we going to do? So we use kubectl in order to execute a terminal. That's kind of the standard in way. And we say use tty in order to do that. That's the T. And here we have to add the ID of the pod. We have to say the namespace, of course. And then we say go into the container Ms Sql. If we do not specify the container, it wouldn't basically matter in this case. But if you have several containers within one pod, this command will fetch the first container that kind of comes along. And if that's not the container that you would be expecting, then you have a problem. And here we have, or we say execute the bash when we are there. So let's see if we can do that. We have the pod. The pod has this name. So we say now before I make any typo, we go to the namespace def, we say exec, we say standard in, we say tty, we give it the name of the pod. We say I want the container that was called Ms Sql, and we say please go to the bash. Okay, that looks not too bad. And then we want to start the Sql CMD. Okay, here we go. Now we can say use, it was called DemoDB. Executed. Okay, we are in the DemoDB. And then I want select everything that you have from orders, I think it was called, right? Executed. Here we go. So we have now successfully deployed the database as a pod. As I said, don't do that in production. I don't think that makes sense. We have, during the deployment, executed all the necessary things. And we are good to go. So we have kind of the lowest layer now in place in our database. And yeah, we can go on now. That's good. Okay, so we have one step done. let's take a look at the next one. So what comes next? Next comes the Ms Sql Api Endpoint. So we have now the persistency in place. Now we go one step above and say we want to expose the functionality from the database with, let's say, sophisticated API endpoint. And in order to make things not too simple, we use Go. That is, let's say, not a programming language that I speak fluently. Yeah, but we will manage to do so. Let's take a look where we are. So we have our secrets deployed. So the secrets are in place. This is something that you have to keep in mind. And now we go to the API Ms Sql Go. Okay, so let's first look what Docker does. What would happen here? As I said, it's written in Go, so we fetch Go image. We set an environment variable for the Go. We change to the workdir app. Okay. We copy the Go mod and Go sum file. We will take a look at that one afterwards. Then we execute some download. Then we copy two things. We copy the command. Okay, that's that one, which contains the main.go. And we copy the internal folder, which contains an API config and a DB. Okay. Then we switch to the app folder. We do basically building of our Go source. Okay. Okay. That looks good. And put that into directory. Okay. And then we go on and copy the stuff that we build it into a dedicated directory. We expose a port, we expose a specific entry point for our app, and that's it. Okay, so I have already executed the Docker stuff, as I said before, so nothing that we have to think about too much. Now let's see what is in there within this Docker thingy. So he copied the Go mod, Go sum. Go mod is a module definition of Go. So it defines the required dependencies for the module that we are building. It also specifies, or I would say this specifies the dependency to the Go version 1.14, and we have 4 dependencies. Yeah, fine. So this is kind of telling you which version, which modules to fetch. We have a Go sum, which are the checksums for all the dependent modules. So nothing that we have to wrap our head around it. So we have some dependent modules. And then we have this command API, which seems to be the main file, as the name suggests. Okay, so what do we have here? We import several dependencies into this package, and we create a main function, which is the entry point for all the Go files, and we define a router. We do a configuration of the router concerning / handling, and then we say, okay, if we create a router, handle the following route with API get orders. Okay, that's within this folder, and this should be supported by the method get. Okay, we do the same for several other endpoints for editing, for deleting, for adding orders. Okay, makes sense. With the respecting HTTP keywords. Okay. And then we have one special handler, which is the order code event, which goes to the API consume order code. And that's the method post. So we have, I guess, one method that especially deals with event handling. Then we have an init database command that's within the DB folder. I think that's Yeah, this one. Okay. And we have a logging. Yeah. So there's one thing that might be obvious, but it's not that one. So all the functions or all the stuff that is exposed from a package within Go has to be in capital letters. If it's in small letters, you cannot expose it. It's not accessible from the outside. That is why you see here only capital letters. Okay, so that's the main file. That's the definition of the routing. So let's see what we have here within this internal stuff. Let's go to the API. We have a server.go. Server.go. Yeah, we have a structure definition, which is the order data, which, if you remember the database, that's exactly it. So we have an order ID, we have a description. And we have all the functions that we have seen before. So we have a get order function with 2 importing parameters, a response writer and the HTTP request, which is here. I think the star means that it's a reference. Then what happens here is we define a variable as a string, which splitting the URL path or the third entry in the array. Okay. We call the DB dependency to get the order from the database. As you can see here, we have 2 parameters here, so this probably returns 2 parameters. Yeah, we have I think that's an array or a slice, and or a slice, and we have the error that's mapped here. If there is an error, we return the error. Otherwise, we kind of use a JSON method that JSON encodes the orders. There are 2 things, as I see, that are returned. First one is the JSON array. The second one is the error. And then we set the content type, and then we write it back to our response writer. Okay, that looks good. So basically, this is the middle layer with the logic in order to handle the API requests. And this is using the DB folder. As you can see here, we have this exposed methods here within the server, and I would expect the same for the events. So we have the consume order event. Again, we have a type definition, which is just the order code. And here we say consume order code. We get again 2 importing parameters. Then we have this little cute thingy, defer. Defer is, I think, a special keyword in Go that, yeah, as it clearly names, defers the execution of this command until all the others have run through. So the body will be closed after everything else is gone. We take the body and we create a new decoder object. Oh, what's that? Yeah. And then we decode the order. The order is handed in here as a reference. So we have here the variable definition, and we hand in a pointer to that. As far as I understand Go, I hope I'm not completely wrong. And yeah, then we do some error checking, and then we do the add order. So we get an event. Yeah. Now we get the event. We decode the event, and then we add an order into the database and say everything's fine. Okay, so this is that one. We have some configuration in here. What's that? That's basically a configuration for the application with respect to hooking up the application to the database, so to pair those things. And then we are within the database area. So we have method that's initializing the database. That's what we saw from the main Go file. So here we have the initialization of the database. We get the connection string from this private method or private function. I don't know if it's private, at least it's not exposed to the other modules. And yeah, this one tries to get the connection, okay. And tries to ping the DB. And this is, okay, this is the layer underneath the API layer that was called by the events and server go, where we have the get order, the get orders, the add order that we can see here. So, okay. Yeah, we have here the externally exposed methods, and within them, there is always this exec call, as you can see here. So we kind of prepare the statement and then execute the statement with this function that returns the rows affected and the error. So this one gets the connection and executes the database stuff like inserting, updating, and deleting. Okay, so we have here a very sophisticated it's a CRUD API layer with one additional functionality in order to get the events handled. So we have CRUD on the orders database that we deployed before, and we have one special handler method that handles events that come in and create an entry into the database when an event comes in. Now let's see what's in the Kubernetes folder. So again, we have a deployment YAML, that's the central part. So we deploy this Go artifact into the Kubernetes cluster using the image that I created before. We expose some ports, we inject some environment variables. Let's see. Those here come from a config map. So we have a config map, so a configuration, which is best practice, as I mentioned last time, to keep the configuration apart from the other things. We'll take a look at the config map in a moment. We also have the secret key refs. So we need those in order to get the username and password into our DB connection. I think this is where it's fetched, or this is where I think you need. Yeah, this is where you need the password and the user ID and so on. So this is injected here. And then we expose and service, so nothing special here. So what do we have here? We have the config map. So as I said, I think last time, we have the config maps, which is also an API object of Kubernetes that's built in, which is just a key value pair. So you can then from a pod consume those config maps as environment variables via command line, or as for the secrets, as a configuration file within a volume. And it's really easy. One point what is important is do not, and that's also described here, do not provide secrecy or encryption. Config maps do not provide that functionality. So if you want to store confidential data, we use the secret. So we are here on the right path with our procedure. The database secrets are stored within the secret file. The configuration is within the config map. Okie dokie. So here we go. This is the config map. We have the database, which is DemoDB. We have this port that we have defined before. If you change anything within any YAML file, be aware that you change it everywhere, because this port is referenced in the other YAML file also. Yeah, I think, and we have the API rule. Yeah, this is also important. We have the API rule, so we expose our API to the outside using two paths, the orders path and the orders slash star path. We have no authentication. These are the methods that we support, okay? And this is the service that we reference to from the deployment YAML. We have again a secret that's the same as before. I don't know why that's stored in here. And we have a deployment service binding file here, and that's interesting because, as I said before, you wouldn't do this deployment of the database explicitly as a pod. You would use a service for that. And this file, we will not use it today, but this file already shows that there is an option to do so. So we have the secret already deployed. So the next thing that we want to deploy is the config map so that it's available for the service. So we go now down to the, what's the folder name? It's API. API Ms Sql Go. Yeah. We go to the Kubernetes folder. And then we do a kubectl or kubectl -ndef apply -f config map. So we create the config map so that the configuration is in place before we do the deployment. And then we do the deployment. So we deploy all that stuff. And then let's see. We should now see the pods running up. Yeah. So we have the SQL database pod running already, and the Go pod is initializing. Yeah, that goes fast. So that's cool. Let's take a look at the development space. The deployment is already done, so it's already up and running. Ooh, that really went fast. We have the service in place. And don't forget, we need to apply the API rule. Otherwise, we cannot access this little thingy. So now everything should be in place. Let's see. We have here now the endpoint that is exposed. So it's not yet there. Let's see. Cannot be found. Why can it not be found? We have the pod running. The deployment is up and running. The service is up and running. Status is okay. So we should... stupid me. Oh man, explaining all the files and then not knowing what to do. Of course. What are we doing here? We are serving only the order files and API rule. We are supporting those paths. So maybe it makes perfect sense to do the path. And here we go. Let's make it a bit bigger. So as you can see, we have now the two order IDs that we have put in before. We should now also be capable of entering one and getting only one. Yeah. So endpoint is up and running. That looks good. Okay. Yeah. Another one in the books. So yeah, let's go to the next step. We have now the database, we have the API. So now we want to have some convenience. We can also deploy a Uf5 front end. Now this is really nothing special anymore. So we can take a look at the code. So what we have is the front end Uf5 Ms Sql. It's a Uf5 app. I'm not a front end guy. I guess all the things make sense. We have a package.json file that probably contains some scripts. Yes. We have a start script. We have a watch. We have a build. What happens within the Docker file? The Docker file basically fetches a node image. It copies the package.json, it installs all the dependencies, and then it runs the build script. Okay, and after it's running the build script, it's setting an nginx, or it's fetching an nginx image, and it's copying all the stuff from the build folder to the app dist and to the corresponding directories here. And then the Uf5 app should be running. So what do we have here for the deployment? So we have the container within Docker registry. What we do is we fetch the image. We say this is the port that is exposed. We do a volume mount in order to get the config JSON file in, and we expose in service. Okay, so that's for the deployment. So this is the deployment of the Uf5 app. We also have an API rule in order to have the endpoint accessible. Here we have now everything accessible, and we have the config map. Okay, now things fall together, where I have the config.json, and this is the config.json, which directs the app to the endpoint of our API. Now this is important. We have to get the API endpoint set correctly. So this is something that we have to change. We have the API rule. We have this one. We copy it. We go here. We put it in here. So let's shortly check. Yeah, that looks good. Okay, that makes sense. So yeah, let's deploy the things. What else is expected? So we go to the front end Uf5 folder. Yep, we go to the Kubernetes. We have our deploy files here. We say kubectl apply. We first apply the config map so that we have all the configurations in place when we do the deployment. If you do it the other way around, the pod will not be able to start up. So that's because it's missing configuration. So you can kind of heal the system by then deploying the configuration map and then redeploying the deployment itself so that it fetches up the config map. But well, why should we do that if we can do it right in the first place? So we do now the deployment, which does the pod and the service, and then last we do the API rule in order to expose things. So now we should already have some pods running. Okay, that's also starting quite nice. So we have now our database. On top we have the API layer so that we do not have to expose the database directly. And on top of the API layer, we now have the Uf5 front end. That is hopefully due to our change within the config map, due to our change within the configuration, looking for the right API endpoints that are exposed via our API rule, this one. So let's see if thing is already up. Yep, it's up and running. So we have now our two orders. Now let's see if we can really interact with the API. Let's take that one. Oop. Let's test order from the UI. Seems to work. So this should also then be perfectly here. Yep, it's here. Test order from the UI. That's cool. Okay, so let's shortly recap. So we have now the database which stores our orders. We have an API layer on top, and we have the UI. And we can interact. We can bring things together. Now where's the fun? Where's the eventing stuff that I mentioned at the beginning? So we have to go to, so we have the mock in place. So if you remember last time, let's shortly take a look. We have the commerce mock, we have the APIs, and we have here the somewhere the events from the Commerce Cloud. For example, we have this order created. So this is already in place. So it's available for our Kmya environment as an application, as an external system. It's serving, but we have no namespace binding up to now. Okay, so what's next? We have this thing in place. Now, what we want to do is, we do not want to trigger a function as we did last time. Now we want to trigger a microservice with an event. Now, if you remember, when we created a function, we had the option to define a trigger for that function within the UI of the Kmya function environment. Now, how can we achieve the same for a microservice? And this is the last part that we have to do. So yeah, let's take a look again at the code, or to be more specific, at the API code. So what we had is we have this events.go API thingy that obviously deals with the event. Now, how do we glue together this endpoint with an event that might be raised? And this is something where this event trigger YAML comes into place. So it's this YAML file that references now a resource that is not, or an API that is not directly available within Kubernetes, but is a part of Knative. And if you remember Kmya, the overall stack, let's go to the Kmya page for a moment. So what you see here, we have Knative in place, so it's part of the Kmya stack. Now, what does Knative bring us? So there are basically two components. One is the serving component. The serving component builds on top of Kubernetes, as it's written here. It's built on top of Kubernetes and Istio. And it's especially relevant when you want to do something like, let's say, serverless applications and functions. That's where Knative service comes into place. It contains all the relevant stuff like the rapid deployment, the scaling, the routing, and so on and so forth. Again, there are several resources in there, like the service itself, which is the function. This is what happened behind the scenes, at least I guess, within Kmya. We have routes which tell you where to go. we have a configuration. So again, we have a splitting of the functionality, the code, and the configuration, which is, as mentioned here, part of a best practice within cloud native development. And what's interesting, or what's an interesting concept from my perspective, is this revision. So basically, Knative takes a configuration together with a certain code package or a certain, let's say, snapshot of your coding, and puts that together in a revision. And whenever you change something, be it in the code, be it in the configuration, be it in both, you will get a new revision. And the routing then tells when something hits the service where to go, which configuration and which code base to use. From my perspective, that's then also the way how to do something like blue-green deployment or something like that. At least I would guess so. This is also kind of then the atom that is relevant for scaling up, scaling down, as written here. This is, at least I guess, I mean, the look behind the curtains of the managed Kyma is kind of limited. This is what we used when we used functions last time, at least the concept of it. So we deployed kind of a serverless offering, a function, and then we had some configuration for the function, and the traffic or the event was routed to the right code base, to the right configuration. Now what we want to use this time is the second pillar of Knative, and that's eventing. So this is also relevant for cloud native development if you think about event-based architectures, which are one important pillar from my perspective of cloud native development. And what they do is they give you the functionality in order to deal with events coming in. So basically there are several components within Knative eventing that support you there. So they are listed here. So we have on the one hand side event consumers. So an event is raised and somebody consumes the event. Fine. So they have some further, let's say, flavors for event consumers. We have addressable ones. These are objects that basically receive and acknowledge an event. What's interesting here is that the core Kubernetes service object is an addressable event consumer. So the Go functionality that we deployed with this special method for the events, where we have created also the service object out of it, can be used as an event consumer. That's good. There is also the option of a callable, which can kind of receive events and then emit events again. So it can return 0 or 1 new event. Okay. We have event sources. There are, let's open that one up, different event sources, like an API server source. We have AWS SQS. We have Kafka, yeah, classics. We have a distinguished binding, and we have WebSockets. Now you can try to get the sources with your Kyma environment, but what it will tell you is that you do not have the right roles, so it's forbidden to access that. Well, okay, we will not find out what is used there. And we have event brokers and triggers. Now this is interesting. Brokers and triggers are kind of the glue thingies that catch the events and allow you some, well, brokerage or some delegation to a service. So as you can see here, we have a trigger. which is basically a filter on event attributes that you would give forward to the subscribed service. And you have a broker, which simply brokers the events. You can also put in filters in there. This is something that already comes out of the box with Kmya and with all the mechanics within Kmya, so that you can hook up other applications, that you can connect them, bring them together, and that you can consume them. And the trigger is kind of the, let's go here, is kind of the glue code. And this is the YAML file that we just saw. So what we have here is we have this Knative API, and we say we want to create this object that is called trigger. Of course, it has a name. We use the default broker as there is within Kmya. And we say we want to define a subscriber for a specific type of messages or of events coming in. And we have different options how to do that. We can say we want to get a service that is used that has a specific name. And we can also specify a URI, so a specific path where the event should be delivered. So now let's go back to the code, because that is exactly what we have here. So what we have here is we define the trigger. We say we want the trigger to have a name. We say we use the default broker. Now we want some filters. We want the event type version, that's v1. We want a specific source, we want a type, and that's order created. So we want to do some filtering. We want just events of the type order created. We do not want any other types within this trigger. And here is where we glue up the event, the trigger, with our service. And that's the API Ms Sql Go service. And we also specify the URI because we have defined a specific endpoint, especially for those events to be fetched by the code. So now I have to check, because this source is the name of the application of the system. So where do I have my code? Where do I have my Kmya? It's here. So first of all, let's create a namespace binding. So we have the def namespace. We do not want to have all, we just want to have the events. So we create this namespace binding here. And now let's go to the namespace itself. So what we have now, we have basically within the namespace available the MP commerce mock2, and this is now important because we have now to change that one here. Thank you that I cannot delete systems. And we want to create an instance. So we have no service instances here. So we add an instance, we get that one. We do not do anything special here. We create that one and it's getting provisioned. Now, what happens? Let's take a look at the deployments. There are some deployments going on in order to create all that Knative stuff. So as I said before, we are not doing any special with the broker, because Kmya, as soon as I create such an instance, does the hard work behind the scenes. So it creates the broker, the default broker, it creates the gateway, and it's setting up all the things in the backend. So let's see. We have the deployments up and running. We have the pods up and running. This is something that I already have done that several times now. That is usual. So you have some restarts with the default broker. That's something that you cannot avoid. That's not an error. At least I wouldn't think so. It's just that it needs to restarts. And then we have the services that are exposed, like the default broker filter. So all the stuff, as I said before, where do we have it? Yeah, we have this broker, we have the filtering, and so on. We have everything in place in order to make use of the events. So we have here this instance, we have here the object. So yeah, everything is hooked, is brought together correctly. And what we do now is we glue things together. So we now bring in this trigger definition. So let's go to the that was not good. Kyma Runtime extension sample. We go to the API Ms Sql Go. We go to the Kubernetes folder, and we now say kubectl apply, and we apply the event trigger for our namespace dev. So here we now glued together the things. Let's see if we can get triggers. So we have this trigger. Let's see if we can get some more information out there. Yeah. So what do we see here? Let's make that a bit bigger. So we have a name, okay, we have the namespace, it's eventing from Knative. We have some metadata, we have some specification. We have the to, so that should run fine. We have what we've specified within our YAML file. And we have the status. So everything seems to work. The trigger got ready. So now, what should be possible? So we have here 3 entries. Now, if we raise an event, so let's go to the events. Hope I didn't. Yeah, we have the cloud events. We have an order created event. We have the order code, and we sent the event. The event was sent. So now the trigger should have fired. Let's see. Ha! Here we go. We have the event. We have brought everything together. The order was received from an event. Perfect. So this was kind of running quite smoothly. Okay. So as you can see, quite some things have happened here. There was also a label added because the eventing injection was enabled. Okay, so we are done. What do we have here? Nothing really new within the description. We didn't miss anything. Yeah, so we are through. Okay, cool. So in contrast to the last session where we used a lot of abstraction by Kmya, which is cool. For functions, we now covered a bit of a different use case. So last time we had an event and we want to trigger a function, really function as a service or a serverless piece of code that's living within Kyma in order to do something. Now we built an application consisting of a database layer that's living in a pod, of an API layer that has some CRUD functionality exposed, plus one endpoint for handling events, and a UI for convenience. And what we did is, we now, due to an object that's available due to the Knative stack within Kyma, glued together the event that was raised by our commerce mock with our microservice that we have exposed, or our service endpoint. Microservice, what is a microservice? So we have a service endpoint, and that was glued together due to this event trigger that we have here with the event, and reacted on the event. And we could not only use something that was out of the box available, a service object within Kubernetes, but we could also specify at what endpoint it should reach out to that service. So that's really cool. I really like that. So we also learned some Go today. That's also not, I think, not the wrongest language to learn. Okay, so I hope you enjoyed the session today. I hope you learned something. At least I learned quite a lot, especially during preparing this session and now also during the session. So hope you enjoyed it. Hope you will continue your own learning journey with Kyma. I will do so no matter what. And yeah, see you next time when I have another episode ready for learning Kyma. Let's see where my journey takes me. As an educated guess, I would say it will be security, because this is something that we largely didn't think about when we exposed endpoints up to now. Okay, so that's it. See you next time. Have a good time. Bye.